right. Don't say the name because I'm recording. All right. Let's do this one. The first thing you should notice, different from Monday, is that we are being asked to run an interval. So think back to our last unit. What do I start with when I want to run an interval? Don't need the parameters for a test. So don't need parameters, don't need hypotheses. Which yes, that's right, Diana. Well done. The assumptions. So what's our first assumption? Okay. Who's got it? That's the defining the parameter. Wait, Leslie's got it. What'd you say?
One car's gas mileage.
Perfect.
Oh, we're doing tangents?
Yeah.
Yeah, because we don't need the parameters. We don't need hypotheses when we're doing an interval.
Okay. Yeah,
Okay. You still got some months. Okay. Let's see, Catherine. Do you know what we should do after this? Okay. And do you notice anything? It doesn't have the word random?
This samples a good
No.
What's the yeah, it is.
You're good. It's okay.
That was a joke.
You got me. It was a good joke. This is a random sample of 10 cars. Okay. Ziamara, do you know what we do after that? Nice. Do you know what to do with that? Excellent. So what's the sample size that we have here of cars? 10. So it's actually going to be 10 times 10, which is 100. And I asked my P8 class, just think of a brand for cars. Anyone want to pick a brand? Audi. Well, nice. Or we were at Toyota, my P8 class. We're leveling up. Nice. So Audi. So let's think about Audi. Do they make over 100 of these new models? I don't know what the model is. I don't drive an Audi, so I don't know what they are. But yeah, probably over 100. So Audi produces over 100 of these new models. So our sample size is not too large. All right, now I'm hoping that after Monday, after today, right, you should notice that so far nothing's really different. All right, but now there is going to be a change. At this point, if it were proportions, I would be going to say our sample size is large enough, right? But instead, with means, what's my assumption I need to make? Remember from Monday, what assumption we need to make? Excellent. So if we had the gas mileage value for all of the new models that Audi is making, and I made a histogram of that, what does it need to look like? And since this one I want it to be normal, Maria, I'm actually going to take the word normal out of it and just say it should be unimodal and symmetric. All right, it should be normal. Will I know if that's true? No, I will not. So I'm going to say the population histogram of all gas mileage values needs to be normal. Okay. On Monday, remember we did the question about the batteries, right? At this point, after we assumed that the population histogram of whatever we were doing looks unimodal and symmetric, I don't know if that's true. So we actually then do the nearly normal condition, which is just another way of saying make a histogram of the data you have. Did they give us the 10 data values for these cars? Did they give us like, here's car number 1, this much gas mileage car. It didn't, right? It just gave us statistics, right? It gave us the mean and the standard deviation. So am I able to make a histogram? Can I just conjure one up? No, I mean, I could, right? But you don't have to. So if you get this question on the AP exam, you're excited because that's one less thing you have to do, all right? Did you guys see the last sentence? What are they telling us in the parentheses? They're telling us that what I just said, right, that I'm hoping to be true, they're telling us it is, all right? So what I'm going to write is I can't make a histogram. But I also don't need to. Now, I do want to mention a few things before we just move on with this problem, all right? Because when I think about my sample size of 10 cars of this new model that Audi is making, what are your thoughts when you see the sample size is 10? I don't know if it's too small, but I think I'm feeling like that's small, okay? So what if they had said that assume that this population histogram is showing some skewness or maybe some potential outliers? Then I'd be worried. Why would I be worried? Because? Well, yeah, if I'm going to have any outliers or any skewness, it is going to pull in that direction. The big issue here is the sample size being small, right? So if you know or you're worried about the population distribution being not normal, then you're hoping to do what with your sample size? Make it larger, right? So maybe instead of 10, is there a way we can make it 100 or maybe even 1,000? All right, because the larger my sample size is, the less I care about what the population histogram looks like. All right, and that's a concept that you'll see probably on the AP exam in some way. Everybody okay? Questions? All right, so we go to our next statement, which is the conditions have been satisfied. All right, be careful here. So I will use remember we used to say normal model, but no normal model today. We're going to use what letter? A T model or a T distribution model. And then always put with, you got to put your degrees of freedom. Do you remember how to find degrees of freedom? It's 9. How'd you get that? Yeah, nice. I think you guys got it. It's n minus 1. All right, so 10 minus 1 is 9 degrees of freedom. To run a one sample T interval. Okay, at this point, I'm going to move to my mechanics, right? My actual math. Let's math it up. Our sample size is 10. Degrees of freedom then is 9. Your sample size minus 1. It actually gave us the Y bar. What was the average miles per gallon for these 10 cars? 27.2. And no, Thomas, you cannot round that. And then what was our standard deviation? 1.8. I don't expect you to have the formula memorized yet. All right, but hopefully you'll do this enough that you'll know it, right? Because the AP exam is going to give you the generic version, which isn't really helpful. Okay, so we have Y bar plus or minus. Now normally with proportions, this was what? Z star. But we're not using the normal model, so it's going to be T star. And when you do that, always put your degrees of freedom. So in this case, a little subscript of 9 times the standard error of Y bar. I'll put that formula to the side so you have it, which is S over the square root of n. Now, lucky for you guys, most of the time on the AP exam, the scoring guidelines really just need you to either name what you're going to do, or they need you to show them by using a formula. So honestly, if you name it, this really isn't that critical. All right, but you know me, I'm trying to show you all the steps, not just how to get a 5 in the AP exam.
Don't give them a reason to not give you the.
Exactly. You know my mantras. All right, so we have 27.2 plus or minus. Now, normally, what will we write here for a 95% confidence level? 1.96. If this was about proportions, that's what I would put. But right now, I'm going to leave it blank. I don't know what it is, because every time we change the degrees of freedom, our model changes. So that means our t-star is going to change. So we're in a moment, we're going to find a t-star. But if I did another 95% confidence interval for a population mean using a sample size of 50, it'd have a different t-star. Right? Degrees of freedom drives everything here. Drives. Nice. Times 1.8 over the square root of 10. Now, you don't have to do this for this problem to get full credit, but I do want to show you how to find t-star, because there could be a question on the AP exam, we'll do one tomorrow, where you actually do need to have this skill, okay? So to the side, if you've got any room to the side or maybe like a corner, right, just quickly draw that sketch. Again, what did I just draw? What did I just draw? The T model. I know it doesn't look different. Okay, 95% is our confidence level. So how much is in each tail for this T model? Excellent. Yeah, you can change it to a decimal if you want. But you've got to split 5% in half. Okay? So now, at this point, I'm going to go to the calculator, and the calculator is going to tell me what my critical value is. All right, so turn your calculator on. All right, so I know the area under the curve, and I'm trying to find a critical value. So I'm going to go to second vars. Now, normally, if this was a normal model, thanks, I would be using inverse norm, right? Inverse norm to find a z-star that I don't know, right? I have memorized 90% confidence level and 95%, but I don't memorize anything else. I use inverse norm to help me find it. Now, we're not using the normal model. We're using the T distribution model. So just go one down from that, inverse T, which is number 4. So second vars, and then number 4, which is inverse T. All right, the area, and you know I'm always going to choose this one. Here it comes. I'm always going to choose that one, 2.5%. But you can also do the one that's up here and do 97.5%. Your choice. You could the same thing. One's a negative, one's a positive. 0.025. What's our degrees of freedom? 9. And this will give us our t-star. 2.262. Yes, second vars. Again, that's not necessary, but it could be, that skill could help you get one right on the AP exam. All right, so let's go ahead and run the interval. I'm going to go to stat, tests. We're doing a one sample T interval. So I'm going to scroll down until I find intervals. Okay, here's the Z interval. Do I want that one? No. What about number 8? Do we feel good about that one? Yes, it says T interval. So I went to stat, then test, then number 8. Did they give us 10 data values? No, right? So it's different than on Monday when we had 12 different data values for our batteries. So we need to go over to stats to the right. Click enter. We're essentially telling the computer I'm going to be typing in statistics. So our average was 27.2. Standard deviation 1.8. And sample size 10. Do I need to change the confidence level? No. Now you're going to see when we get this, it's going to give us the answer. The thing that annoys me, I wish this technology would give you, it'd be awesome if part of this would be to give you the T-star, but it doesn't. So if you want to find T-star, you got to do that process on your own with inverse T. All right, so there's our confidence interval, 25.912 to 28.488. All right, anyone want to give the sentence a try? Okay, hold on. I am 95% confident that the let's throw the word in population in there. That the population, and I never said you couldn't use P words. I told Victor when he said the other P word 3 times on Monday, that not only was he out, but he needed to use population. Stop with that. No, Victor. Population, and we're talking about averages here, so I like to say mean or average, that the population average, what is this? Fuel efficiency, what is it? Gas mileage? Gas mileage? For, let's say, the new Audi models is between 25.912 miles per gallon and 28.488.